Hi students, today we're going to study about what a prism is, how it refracts light, how does it break up light into those 7 colors. We'll study all these things. First of all, what is a prism? If I asked you what a prism was, you would say, it's a triangular object made of glass which refracts light, and for some reason it splits up light into these 7 colors. That is practically the definition of a prism for our use. Actually though, a prism is any object made of glass which has 2 polished refracting surfaces, and this special kind of prism that we use for our IIT JEE problems is called a triangular prism. In fact, this is how a triangular prism looks like. This side that you see, this triangle, is just the base of the prism. The complete prism looks like this. So as you can see, this oblique side of the prism extends backwards, and similarly this side also extends backwards, and this is the side that we see most often in our IIT JEE problems. So let's now study how a light ray gets deviated in a prism, what happens to it. Let's study all the formulae involved. First of all, let's minutely look at how refraction takes place through a prism. Let's say a light ray is incident on this side AB of the prism. Its angle of incidence is I with respect to the normal at the point of contact. Now it gets refracted first at this surface AB, like this. As you can see, the angle of refraction is R. Now this ray passing through the prism again gets refracted at the surface AC as it comes out of the prism, like this. The angle of incidence at the surface AC is R dash, as you can clearly see, and the angle of emergence is E. So a ray is incident on a prism, it gets refracted in a prism, and it comes out like this. Now what has been the net deviation suffered by this incident ray here? So if we extend this incident ray forward and we calculate the angle between the incident ray and the emergent ray, we find delta. Delta is the net deviation caused by the prism. This is a very important quantity for any prism, the angle of deviation. Let's try to calculate this angle of deviation for any random prism ABC. Now you see, if you look carefully, R plus R dash is equal to A. How does that happen? You see, if you look at this angle here, you'll notice that R plus 90 degrees plus this angle, let's call it angle A1, and this angle, let's call it angle A2. So R plus 90 degrees plus angle A1 is clearly equal to 180 degrees, right? There's no doubt about it. Similarly, R dash plus 90 degrees plus angle A2 is equal to 180 degrees. There's no doubt about that either. When you add both these equations, you get R plus R dash plus angle A1 plus angle A2 is equal to 180 degrees. That's because 90 plus 90 make 180 here, which gets cancelled with the 180 on the right side, leaving only 180 degrees on the right side. So as you can see, you can clearly obtain this expression, right? Now if you look carefully, angle A plus angle A1 plus angle A2 is also equal to 180 degrees, because these are the angles of a triangle. So that clearly tells you that angle A is equal to R plus R dash. Here you go. Now what is delta? Delta is clearly I plus E minus A. I know we're using a lot of complex geometry here, but then you'll have to pay attention, because that is how we'll be able to obtain an expression for delta, the final angle of deviation of the light ray, after it's passed through the prism. So how did this expression come into being? Why is delta I plus E minus A? Now if you look carefully, delta is clearly equal to this angle, let's say angle P, plus this angle, let's say angle Q. This is because after passing through the surface AB, the incident ray gets deviated by an angle P, right? It could have gone here, but it goes like this. Similarly, after passing through the surface AC, this ray gets deviated by an angle q, because it could have gone like this, but it goes like this. So clearly delta is equal to angle p plus angle q. Now what is angle p? Clearly angle p is I minus r. This is because this angle here is I, so this angle here must also be I. Delta is I minus r plus angle q, and angle q, if you look at it carefully, is equal to E minus r dash, because this entire angle is E and this angle here is r dash, virtually opposite angles. So angle q is equal to E minus r dash, and if you look at this carefully, this comes out to be I plus E minus r plus r dash, and this we proved just now to be A, and that is the reason why delta equal to I plus E minus A. Now mu is sin I by sin r. We are very clear about that. Mu is also equal to sin E by sin r dash. You see, at this surface, mu air divided by mu glass is clearly equal to sin r dash divided by sin E, and mu, as we already know, is mu glass divided by mu air. So therefore this whole expression is equal to 1 by mu, and that is why mu is equal to sin E divided by sin r dash. Now we've written so many formulae. What are we going to do with them? Let's substitute the values of I and r dash in this expression. So you see, we can write I as sine inverse of mu sin r, right? Similarly, we can write E as sine inverse of mu sin A minus r. This is because we can write E as sine inverse of mu sin r dash. You see here, and r dash is nothing but A minus r, because r plus r dash is A, and A remains as it is. So what we've simply done is we've taken help from some geometry and written the expression for delta, and then we've written these angles I, E in terms of r, the angle of refraction at the first surface AB. Now what if delta is minimum? We just derived an expression for the angle of deviation delta in terms of sine inverse of mu sine this and that. If delta is minimum, d delta by dr will be equal to 0. So in the expression that we just derived, if we differentiate that expression with respect to r, then the differential should be equal to 0 for delta to be minimum. When we differentiate the expression that we just derived with respect to r, this is the actual expression that we get. I know it's all very complicated, but all we've done is differentiated the expression you just saw before. When we equate this expression to 0 and simplify, this is the final expression that we get. I know, again, simplification also involves some mathematics here. You can use the formula a square minus b square equal to a plus b into a minus b. You can use that formula to simplify this expression. Similarly, even this term is of the form a square minus b square. So when you can simplify both these expressions using this identity, and then you can further simplify the final expression that you get here. For example, in this case, a plus b will be cos r plus cos a minus r. So you can actually use the formula for cos a plus cos b to simplify this expression. So when you just simplify this expression without any fanfare, this is the final expression that you get, and this comes out to be equal to 0, because d delta by dr is equal to 0. Now this expression indicates that either 1 minus mu square is 0, or sine a is 0, or sine a minus 2r is 0. Now if 1 minus mu square is 0, then mu is equal to 1, but we know mu, the refractive index of the glass of the prism, is definitely not equal to 1. It will be something like 1.5 or 1.6. Sine a can also not be equal to 0, because a, the angle of the prism, this angle is definitely not equal to 0. So the only expression that can be 0 is this one. So a minus 2r equal to 0. or A is equal to 2r, which also tells us that r is equal to A by 2. Interesting, isn't it? This should be the angle of refraction after refraction through the first surface of the prism for the final deviation of the incident ray to be minimum.